I'll talk about the effect of an El Nino Southern Oscillation and Madden-Julian Oscillation on winter forecast scale. In the past winter, we've seen many ENSO-related events, such as the displacement of close to 200,000 people across South America, South Africa, to struggling with the worst drought in decades. India having relatively less rainfall than usual. Australia struggling with um, uh, bushfires and flash floods. So before we move on to discuss how such oscillations can improve predictability or forecast skill, let us briefly discuss what these oscillations are first. So the SST in the central and eastern equatorial Pacific cycles between above and below average temperature. And El Nino state is when it is above average, and La Nina is when it is below. The panel on your right is the SST anomaly. The red curves show you the El Nino states, and the blue is the La Nina. Let me turn this on. So this is an MJO, which is essentially an eastward moving pulse of cloud and rain near the equator that typically reoccurs every 30 to 60 days. So the ENSO and MJO interaction is between two very different time scales, but it is in the similar tropical region. Their strong extratropical interaction make them important factor in predictability. Okay, going forward, this plot basically shows you the northern hemisphere winter atmosphere analysis. So the y-axis, the y-axis here is the correlation between simulated and observed data, and the x-axis is the lead time. So 0 being when the model is initialized, and the subsequent numbers being the subsequent days that the model is run. So we have divided the entire MJO cycle into 4 phases instead of 8, which is the convention. And different phases just imply the different places the convections are while propagating from the Western Indian Ocean to Central Pacific. And on the left, I've sort of described where each phase convections are. This plot shows that in phase 4, that is when the convection is over Central Pacific, the data has better scale and longer lead times. So separating this into El Nino neutral and La Nina condition, phase 4, that is when the convection is over Pacific Ocean, gives a lot better predictive, forecast skill than otherwise. So we tried to see why this was happening, and we saw that the persistence in phase 4 and in El Nino conditions was a lot consistent and better. So in a nutshell, let me put this in this way, that it tells us that when the MJO, that is when the convection is over Central Pacific and El Nino conditions, it gives us a much better forecast than when the atmosphere and on the top of the that would be all.